In this video, we are working on solving trig equations, and the problem says, find to the nearest hundredth all possible solutions to the following equation in radians. And it says the equation is 3 times the quantity sine of a plus 2 is equal to 3 minus the sine of a. To do this problem, it wants us to give the answers, the final answers, in radians. And that's just fine. But as a strategy, let's go ahead and solve this for a, but we'll solve it for a in degrees, and then in the end we'll convert from degrees to radians so we get the answer that they're asking for. So we're going to go ahead and solve this for a in degrees. So we need to make sure that the calculator is on the correct mode. So go to mode, and then make sure that it's on degrees. Right there, this one is on degrees, so that's no problem. Second quit, and we're ready to go. Okay, so we need to isolate the sine of a. We need to isolate the function part first. So to do that, the first thing I'm going to do is distribute this 3. So we get 3 times the sine of a plus 6 is equal to 3 minus the sine of a. To isolate the sine of a means that we'll have just one sine of a on one side. I'll get rid of this negative sine of a by adding the sine of a to both sides. 3 sine of a plus a sine of a is 4 sine a. We can bring down this plus 6. This is gone, so we just have the 3. We need to isolate this sine a here, so we'll subtract 6 from both sides. We have 4 sine a is equal to negative 3. Again, we're isolating the sine of a, so now we'll divide both sides by 4. And we end up with the sine of a is equal to negative 3 over 4. This does not remind me of any special angle values that I have memorized, and so we're going to use the inverse sine using the calculator. So on the calculator, we'll take the inverse sine of both sides. This is the inverse sine of the sine of a must be equal to the inverse sine of negative 3 over 4. The inverse sine of the sine of a is a. And the inverse sine of negative 3 over 4, for that we use the calculator. We're attempting to determine what this is, the inverse sine of negative 3 over 4. That's second inverse sine, and we put in negative 3 over 4. And that comes out telling us that this is, it says that this is negative 48.59. I'm going to go ahead and I'm not going to round. The reason I'm not going to round is because we want to, in the end, convert to radians, and in the end, we will round. And if you round too many times before you get to the end, you can lose accuracy and be off a little bit. So the answer that the calculator gives us is this negative 48.59037.789. I'll write that down here. Negative 48.59037.789 degrees, right? We really don't like to have answers that are negative angles, and so let's find an angle that is coterminal with this one, but is positive. And to do that, we'll add 360 to it, right? So we're going to add 360 to this guy. So the value that we end up with after we do that is, I'm just going to take what I have. If you just press plus after that, it says the answer, this answer, plus 360 more. So we're adding 360. Oh, that comes out to be 311.40962221. So I'll write that down right here. That's 311 degrees, 0.40962221. Okay? So this is one of the possible angles. Call that one A. Let's try to find the other. Now this is a sine, so we have to reflect across the y-axis. Drawing a unit circle, placing it centered at the origin. Let's estimate where 311 is. Well, 311 is coterminal with this negative 48, and negative 48 is to start here at the x-axis and then go down 48. I estimate that's about there. This is negative 48.59037789. And that means that from there around is 311.4096221 degrees, right? This larger angle. It's a sine, so how do we reflect that? We reflect that through the y-axis, and we end up right here. And we need to find what is the size of this new angle, right? Well, think about it. If this is the 48.59037789, that's this. That means that this is the same thing, right? Because it's a reflection. So this angle also has a size of 48.59037789. But from there to there is 180 degrees, so we'll just add 180 plus this here, and so we'll end up with, let's see what that gives us. We're looking at 180 plus 48.59037789, and that gives us 228.59037779. Right there. I'm going to write this other value down. So this is A is equal to 228.59037779. Just as a reminder for why I'm writing out this decimal so long, I'm intentionally not rounding so that I can round the answer in the very last step and the answer will still be accurate. Okay, so these are the answers in degrees. These are not the only possible solutions. It did want us to find, if you look up here, it says find all possible solutions, which means we also want to include, if you add all of the coterminal angles, so plus 360n, plus 360m, this would be okay if the answer was just in degrees, but we want to have these answers in radians. And so to do that, we have to multiply this angle by pi over 180, right? So let's see what that gives us. So here's for the first one, this is 311.4096221. We're going to multiply this by pi over 180. That is simply done by using the calculator, so I'll do that right here. This is, again, this is, trying to put it someplace where you can see, this is 311.4096221, and then we're going to multiply that by pi over 180. And that comes out to be 5.435123228. But this is the number of radians, and this is the appropriate time to round it. What did it ask us to round it to? Oh, it wants us to round it to the nearest hundredth. So we'll round this to the nearest hundredth. That's the whole number, that's the tenth place, that's the hundredth place. Oh, I see, that's a 5, so I need to bump this up. So it becomes approximately 5.44 radians, right? So one of these, A in radians, is 5.44. The other value here, we have to do this one, convert this to radians. It's the exact same process. So this is 228.59037779. Multiply that by pi over 180. See what that gives us on the calculator. So here we have 228.59037779 times pi over 180. That's how you convert from degrees to radians. And this one says that comes out to be 3.989 here. And let's see, that's right, that comes out to 3.989. This is the tenths place, that's the hundredths place, that's what we want to round to. Since that's a 9, we definitely want to bump this up. And so rounded to the nearest hundredth, this is 3.99. So the other possible solution This is in radians. The other possible solution in radians is a equals 3.99 to the nearest hundredth. And now, how about this part? When we're adding on that 360n, well, how many radians is 360? To help you remember, I'm going to quickly draw a unit circle. All the way around the circle is 360 degrees. How many radians is it all the way around? It's pi radians and then another pi radians, so that's 2 pi radians. 360 is the same thing as 2 pi, so it's like 2 pi n. No one ever writes 2 pi n. You would usually write it as plus 2n pi, the exact same thing. So there is one of our solutions, and here plus 2n pi, so there is the other solution. There was a lot going on in this problem, not because the equation was hard to solve, but because it wanted to give us the answers in radians, and we did it by solving it in degrees first, and then converting to radians. And there we have it.